series is presented by E-Extension's Farm Energy Area of Community of Practice. The series has been a collaboration between Kansas State University and the University of Nebraska. Many of you are tuning in as part of the regular Bioenergy Friday series, coordinated by John Hay at the University of Nebraska. And as many of you are well aware, we've had a few technical difficulties, and we appreciate you bearing with us on that today. Today's speaker is Ted Thompson from Konza Renewable Fuels in Meriden, Kansas. Konza Renewable Fuels is a company developing processes for torrefying biomass. The company also provides torrefaction systems equipment for U.S. and European clients. The company will provide equipment design, fabrication, facility startup, and operator training for the torrefaction systems they offer. I'm also under the impression that they do a little bit of maintenance services as well. With that, I'll turn it over to Ted Thompson. Good morning, Ted.
Good morning. Thank you, Ed. Well, as Ed said, my name is Ted Thompson, and I am one of 7 partners with Konza Renewable Fuels. Konza started in basically January of 2010, and our goal was to create some industrial equipment that could process different types of biomass into a torrefied product. The torrefied product is valuable as a replacement to coal, in essence. So I want to just talk a little bit about about electrical power and about the different kinds of renewable fuels and things that are out there, and then get more specifically into torrefied biomass. So, when we started this process, we were thinking about different ways to help create a better fuel for the environment. We're all using a lot more electrical devices. There's electrical cars. People have iPhones, iPads, iPods, all kinds of different smartphones, laptops, and things. And we're using more electricity, and it's not just in the U.S., it's worldwide. More companies, or more countries, and more people are getting, quote-unquote, wired, and are using more electrical devices. And, electricity seems great, but is it really clean? And that really depends on where it comes from. Here in the U.S., we consume around 1 billion tons of coal a year. And that's an awful lot of coal. So, to explain this even a little bit more, I live in Topeka, Kansas, personally, and Topeka is a city of about 130,000 people, and it would take approximately a 500-megawatt coal-fired power plant to supply the energy needs of a city like Topeka in a year's time. Now, near Topeka, we have the Jeffries Energy Center, and Jeffries has 3 720-megawatt power units up there. And but I kind of just wanted to give a little bit of breakdown here about all the different kinds of toxins and things that you get that are when you're using coal, and you're using coal on that kind of level. You've got thousands of tons of sulfur dioxide and nitrogen oxide and all kinds of different heavy metals. There's problems with ashes and sludges and what do you do with those kinds of things when they're left over. A lot of the stuff is released into the atmosphere, or it has to be cleaned up and scrubbed up and then before it's released in the atmosphere, but then that stuff still has to go somewhere. So that's one of the things that got us interested in torrefying biomass, is to kind of find some sort of replacement for coal. As many of you also probably know, there's a lot of renewable power out in the world these days. We've been using wind and solar and hydro and geothermal for years, and we've also been using biomass. Each one of these different things has got its own pros and cons with it, but the people who are involved in Konza, our expertise is really in biomass, and that's one of the reasons that we obviously focused on that, and we wanted to focus in on torrefied biomass. And there's a whole slew of potential biomass things that can be used, and most of those things can be potentially torrefied too. But to us, it seemed like torrefaction was the most likely candidate for success as a replacement fuel. And our goal really is we want to protect the environment. We really believe that we need to be good stewards of the earth and its resources. And to do that, that means that we need to have fuel sources that are renewable, that are clean or cleaner, that are safe for people and the environment, and that are available for people to be using. Biomass is something that, in most parts of the world, there is excess biomass and it can be used. So a little bit about what torrefied biomass is. I'm going to explain a little bit about the process. What we do is we apply heat, and in this case you're seeing some wood there, but we've also done this with some other kinds of agricultural waste. But we apply heat and we go through a stage where it gets to what is called torrefied product. This is after it's been dried. We run our stuff through drying systems first, and then we put it through a torrefaction reactor. But we stop it. It's not charcoal. It stops before it gets to that charcoal process. During this process, we drive off about 30% of the mass. So if you put a bone-dry pound of wood in, you're going to get about 0.7 pounds of torrefied product out. We also drive off about 10% of the energy out of that wood. So when you have and then what happens with this process is, since you have less, since you're consuming some of the wood or the biomass when you're going in, when you combine it back together to make a pound of torrefied biomass, you actually end up densifying the energy in essence. So if you went into it with wood that was about 8,800 BTUs per pound, you'd end up with wood that's you'd end up with a torrefied biomass that's somewhere around 10,000 BTUs per pound. But of course, you have to use about 1.3 or more pounds of wood to make that pound of torrefied biomass. And just a little bit about who we are as Konza. Konza, like I said before, we're a group of 7 partners who all have a commitment and a vision to having a cleaner environment. 3 of our partners have a combined 70 years of experience designing and operating industrial equipment. 4 of the partners have a combined 80-plus years of experience fabricating and installing industrial equipment, and 3 of the partners have a combined 60-plus years of experience handling and sourcing biomass. So we've got a lot of experience in these particular areas, and it's one of the nice things about the equipment that we're making. We're not starting from scratch. We're actually able to use a lot of our existing experience and knowledge to do that. What we've done is we have built a scalable pilot unit. We saw a little bit of a picture of that in the first slide at the beginning. That particular unit came online in August of 2010. We have since moved it to a different location. We have added some energy recovery equipment and a thermal oxidizer to it to clean up all of the gases that come out of it. We're in the process of, once again, just learning how to create the proper kind of torrefied material that we want out of a variety of different feedstocks, whether it's different types of wood or different types of biomass outside of wood. Basically, part of the process that we use here, we start off with a drying system, and we dry the wood down to in the 2% category. Then it goes into our torrefaction reactor. We take the gases that come off of the torrefied wood and we reuse those. So that 10% energy that we drive off, we actually are able to reuse that. And we use all of that up in the system that we've designed when we put the energy recovery system on it. and it keeps us from having to put a lot of excess additional fuel into the system. At some moisture contents, the system is almost autothermic, where we really don't have to put any extra energy into it as far as fuel energy, like natural gas or propane or something like that. We obviously still have some electricity to turn fans and conveyors and drives and stuff like that. But it's been so far it's been a really interesting process to learn and to make work properly. And the unit that we currently have is doing great, and we're excited about the progress that we've made with it. We are, to give you guys a little bit of a look at some stuff. Our big competitor in essence is what's called white wood. That's either usually sold in chip or pellet form. Most likely it's in pellets. And depending upon where you are in the world, and these prices change all the time. So as soon as you put them down, they're different. But white wood pellets are going for somewhere around $170 a ton on average around the world. They can contain anywhere from about 8,800 to 9,600 BTUs per pound, depending upon the type of wood it's made from. They need covered storage for a utility to use them, so they don't, get wet and absorb too much water. And then the problem that many of the utilities are having, if they try and mix it into an existing coal-fired system, the lignins and other things in the woods will really gum up their grinding equipment, usually someplace in between 5 and 10% mixture with coal. And this is where we start to get to the heart of the matter of what we were trying to do. There are a lot of existing coal-fired power plants out there, and to modify those plants to accept wood would cost an awful lot of money, and would create some of them space issues. There's a lot of power plants that are very landlocked and don't have a lot of space. Especially when you get off to the East Coast or in some of the bigger cities, you've got power plants that just can't find that extra space for stuff. So, and then they'd need to find some way to cover it or something. So this is where the torrefied biomass comes in. Now, torrefied biomass is going to cost a little bit more per ton, but it also has a little more BTU value per ton. And one of the things about it is it's hydrophobic. It does not absorb water like wood does, like regular wood does. It rejects it, and this means that it's something that can be stored outside. It can be basically mixed directly in with coal at that point. And the early testing that companies have done on it is showing that it is not causing any kinds of gum-up issues with their grinding equipment, and that's allowing it to be a product that they literally can bring on site and mix with their coal. I know that one of the things that we've talked with a few coal companies who supply coal to power plants, and they've been interested in torrefying material and being able to sell a blended product to the different utility companies. So now the next question that we looked at was, is there a demand for this? And many companies have what's called a Renewable Portfolio Standards, an RPS. And an RPS is, it's a regulation that requires certain amounts of energy to come from different renewable fuel sources. A lot of these regulations specify that certain forms of energy have to be used. There's stuff that says X amount has to come from wind, or a certain percentage has to come from solar, or a certain percentage has to come from biomass. 36 of the 50 states here in the U.S. have some form of RPS in place. Here in the U.S., we usually call it a Renewable Electricity Standard. And the requirements can be for the whole industry, or there are several requirements out there that deal with particular companies in that state that have to do certain things, which may be above or which be higher or lower than what everybody else has to do. And most of these standards are basically are gradually increased over the years. And I've got list here of the 36 states. I'm not going to go through all of them, but as you can kind of see, each one of the states has some sort of percentage of renewable fuel, and they usually have, and they've got the year that it's supposed to happen in. So there is, we feel that not only is there demand in Europe, where there's, I think, more demand for this right now, there is going to be a coming demand here in the United States for this type of product. But, as you can see, a lot of this stuff is 2020, 2025, which means that it will be, just a couple of years before that the utilities will really be saying that they need this stuff. Because they'll basically wait, and you can just kind of see there's just a whole slew of the states and what they're all doing for this. So, the potential users for this particular product are utilities, and that's the big target market that the end product is going after, but that's not actually who our customer is. Our customer is the people that want to supply to the utilities. Steel mills also use a lot of coal, and they don't just use it to make steel. They use it, to fire their boilers and stuff like that. And there's a lot of other process plants that are out there that use coal-fired burners to heat their boilers. So any of those particular types of companies or processes are the end customer for torrefied biomass, and we personally are looking to find people that want to supply to those guys. And one of the, like I said, one of the users that we're looking at is the people that are already supplying coal. Where we are now as a company, we are currently starting up that scalable pilot plant here in Kansas. I showed you some pictures of that earlier. We're just going through some of the startup phases of introducing the new equipment to it. We are going to be doing some testing for permitting by Kansas Department of Health and Environment in July. We are starting to line up customers who want to purchase samples of the product. This particular machine is designed to be able to produce samples for customers on a small scale. We can't meet like production runs of anybody, but not only are we, we're kind of in a situation where we have to prove that the fuel is a viable fuel for utility companies or other coal users to use, and they need to have samples of it that they can test and make sure that they're happy with it and can move forward. So we are currently, the scalable unit that we have right now will do about 3/4 of a ton an hour, and we are currently designing a 4-ton per hour modular unit that's that's not mobile, but it's a term that we call luggable, where you can move it around if you need to. It's not terribly easy, but it can happen. And then we're also looking at a 12-ton per hour unit that would be more of a permanent fixture in a place. And the reasons are is we've got customers that are interested, potential customers, I should say, that are interested in both kinds of units for out there. And we're actively, marketing our systems for sale right now, and more along the line of we're really kind of prepping to be ready to do that more. Some of the things that we're waiting on is really to be through with the startup of our pilot plant here, and also with the testing from KDHE to get all of our ducks in a row, as they say. So that's really the end of my presentation. I was trying to hurry a little bit because I know you guys have a schedule and we got started a little late. But if anybody has any questions, I also have Josh Thompson with me, and he is one of the engineers in Konza that helped design the technology, and we would be happy to field some questions.
Ted, I have a question while we're waiting for others to maybe enter a question into the chat box. If you have a question, please type it in the chat box and I'll read it to Ted. The question I have is I've been thinking a lot about corn stover and wheat stover or wheat straw and those types of materials. Can you speak to that far as how that works with your system?
Yeah, we have actually torrefied some wheat straw and corn stover. We've had decent results with it. Our system is, from a material handling standpoint, our system is designed more to handle wood right now. But we've been able to do some testing with those things. We've also done sorghum and I guess this is sorghum, yeah, sorghum, wheat straw, and corn stover, and we've had pretty good results with that. So we certainly feel that any kind of biomass is definitely a potential for it. Obviously, the different types of biomass have different BTU contents, and it's just going to be a matter of what the price is that you can get that stuff for and sell it for, and so as to whether it's a viable fuel product.
Okay. I have a question here that's asked, do you plan to add densification equipment to the process to make torrefied pellets?
We have done some limited stuff with densifying. We've made pellets. That is one of the next steps in this particular stage. There are quite a few pellet manufacturing companies that have also been working on this, and we've been in talks with a couple of different ones to kind of form a joint research venture on making that work. So we do intend to. That's one of the next steps that has to be looked at for it.
And I'll add to that it won't necessarily be a pellet at the end of it. It will be what the market needs and what is able to be produced. It could be a briquette or a puck or cube or who knows what. It just depends on the market as well as how the stuff densifies.
So essentially, a retail market may be more of a pellet, whereas a utility market might be more of a briquette or puck type material.
That is correct.
You made a comment in your presentation about the process being autothermic at certain moisture contents. Can you elaborate on that a little bit?
Sure, we can talk about that a little bit. When most of the wood and stuff that we get, if it's especially if it's fresh cut or something, is going to be 45 to 55% moisture content. And at those kinds of levels, we definitely have to put additional energy into the system to drive that water out. If you get down low enough to the system, and it's somewhere in the 35% range, we do not have to put any additional, once the system's up and running, we're not really having to put that much more additional energy into the system to not only dry but to torrefy the product, because we're reusing those torrefaction gases that are driven off. So it's somewhere in those areas that we have that we're able to get a somewhat of an autothermic process with it. Does that answer your question enough?
Yeah, sure does. The next question I have, and still opening up for people out there that have questions, is regarding the 4 and 12-ton units. Where do you envision those going, without, of course, getting into your marketing plans and such? But can you speak to how you envision your process being out in the world and people utilizing it?
Sure. There are a lot of potential customers out there for us, and the kind of customers that we're looking at are people that are like one of them, like I said, is people that are already producing coal and are realizing that they need to do something to potentially sell a cleaner system or cleaner product. Because if we're able to do the biomass, you're looking at them losing some of their market share, and instead of them losing it, they can supplement it, and not really lose. But by the same token, the other customers are people who have existing pelleting plants and operations, people who have other kinds of forestry operations like pulp and paper mills or engineered board plants. There are a lot of plants that are sitting idle and across Canada and across the U.S. that there's a lot of people who are trying to purchase those and turn them into something where it's producing wood pellets or torrefied biomass. So those are kind of where we envision a lot of these kinds of systems going, is to places like that and customers like those.
Okay. We have a question from Brett. He says, can you touch on any of the emission gas cleanup issues with the torrefaction process?
Say it again, please.
Gas cleanup emissions for the torrefaction process.
Yeah, one of basically the torrefaction process is the beginning stages of wood combustion, and what we do is we drive off a lot of the volatiles, which are hydrocarbons, and in one of the slides that Ted showed, we show our energy recovery system, and so as part of the torrefaction system, and integral into the torrefaction system, is our energy recovery system, where we run those torrefaction gases through a combustion chamber, where we raise the temperature of those up to at least 1,300 degrees and hold them there for about a second. In that time, that we will destroy upwards of 90% of any of the torrefaction gases in that gas stream. So we expect the emissions to be off the torrefier to actually be less than what a standard even dryer system would be without any secondary cleanup equipment on it. And we're designing this so as to not have secondary cleanup on it, just a primary system.
Okay. We have another question here. You mentioned that your 4-ton system will be modular. Does this mean that the system will have parallel streams of processing, 4 streams of 1 ton each?
No, it'll be one unit that will produce 4 tons per hour.
When you mentioned that I think you referred to this as a luggable system. How large is this? Are we talking a couple tractor trailer loads worth, or a single tractor trailer load, or?
It'd probably be 5 to 6. The concept is we've had one of the reasons that we started developing this particular size is we've had some potential customers who talked about where they had some areas that they'd like to go in and do stuff for a year or two and then move the unit to a different location. So we wanted to make something that was reasonably easy to move, but not something you want to move every day, obviously. And that's why we came up with that particular size. And it's really kind of the largest unit we can get on a tractor trailer, and without having to get a lot of extra permitting for it.
Sure. So it'd be something like if you were in the mountains and you were trying to reclaim wood, you could move into an area and harvest in that area, and then move to another area.
Yep.
Okay, we have another question here. As a luggable system, how much electricity demand would you have for that?
Good question, and don't have that information in front of me. And I don't recall it off the top of my head, so I can't really answer that.
Okay. All right. Well, we'll wait a minute or two here and for more questions.
But one of the
go ahead.
And I'll answer a little bit because this is something that maybe Bob here was trying to get at a little bit. These systems would be designed to be put into places where there probably isn't any kind of infrastructure. So the electricity would have to be from generators. They'd most likely be running on propane and that kind of stuff.
So it would be that would be just another part that would have to be put in place to make this system work.
Yeah, it depends on where the customer is planning on putting it, but the concept behind these is usually that it's going to be somewhere where there isn't, any kind of infrastructure for electricity or natural gas. We can also use wood to fire the system on too. So it just depends on what the customer wants to use and what they're planning on using it for. And the system would be designed with three-phase.
Okay. Okay. Looks like you covered Bob's questions there. Well, I don't see any more questions. If one more comes in, we'll get to that. But with that, I think we can start wrapping it up today. So, Ted, we really do appreciate you giving this presentation today and talking about the torrefaction process. Doesn't look like we have any more questions coming in. So I think we'll just draw this presentation to a close. So thank you. Well, we may have Bob here. May have a question for us yet. We'll try to get him yet. Oh, thank you, Bob, for asking the questions. So with that, we'll draw it to a close, and thank you very much, Ted.
All right, well, thank you all, and have a great day.